lecture room. A very similar setups I have back at my home country. I'm from Sri Lanka. So I may put in certain theoretical stuff, so bear me with that. Plus to that, I'm Apache committer, which I'm very proud of. And so I'm into web services. So this is what we're going to look at today. So we're going to look at service-oriented architecture, the importance of that in the enterprise development. Of course, you may have heard from many speakers about this, so I can probably rush through the slides on that. And where does web services fits in this? And very importantly, quality of services attribute in the enterprise, which really matters when we are into enterprise software development, and the challenges we have in the current available infrastructure. And this is where we want to think differently. So there are traditional web services containers which are based on JE or J2EE, but we want to think differently. We want to think out of the box. A very different approach to the standard way of doing things. And after that thinking, do we have a solution in place? Yes. And I will introduce that solution to you, which is a POJO, truly a web services container. So, what is service-oriented architecture? In many articles, if you Google about SOA or SOA in some part of the world, you will find many different definitions, many articles written on that. But unfortunately, all of these articles or definitions end up talking about web services. I think that is not very right, because SOA is simply an architectural style. There are many architectural styles, but SOA has become very popular due to some of the key features. By design, it has the capability to handle the challenges in distributed computing. What are the challenges in distributed computing? There are three major challenges the moment you decide to distribute your software or your software components. Those three are challenges in terms of data integrity, challenges relevant to temporal order, or in other words, the time factor in these different computers, because they are running on different hardware. So these software components, when they try to interact with each other, this time difference is going to play a part. And then consensus between applications. How do you come to a common agreement before you perform certain transactions? These are the three main problems. And there are many other problems which are surrounded. But these are the three main difficulties you face when it comes to distributed computing compared to computing in a single infrastructure. So all these solutions out there which facilitate distributed computing are trying to solve this. And there are many research happening. And if you're interested in that aspect, there's someone called Ken Berman who has written a book about distributed computing and a new way of thinking. And of course, he is not in agreement with some of the web services standard impact, but it's an interesting aspect. So anyway, getting back to the talk. So this enables resource coupling by design. And for businesses, the architectural styles give a very important attribute, which is integration and interoperation between businesses. Now, it doesn't stop at business level, it comes down even to technology level. And if you want to integrate across different businesses, across different technology platforms, obviously you need to have some open standards. Otherwise, things are going to simply fail because People are not in agreement with what the message protocol, what the underneath wire protocol, and so on. So the architectural style, therefore, push an architect or a designer to think about these things, and there are certain guidelines and disciplines evolved around this. So this doesn't talk about any implementation technology. It just stay at the design or architecture level. So then what is web services? What's the role web services has here? So as I previously stated, this is my viewpoint, of course. There will be many other viewpoints in the room, so feel free to share that when we come to questions and answers. I have planned few minutes towards the end to hear other viewpoints. So I don't think SOA is web services. And web services is not SOA. It's just a confusion we are in due to different viewpoints put out by different people. But certainly, you can use web services as a technology to implement SOA or SOA. It's just an implementation technology. I have seen many examples where people have used web services, but that is nowhere close to SOA. And in fact, let me ask you a question. Or well, I'll keep the question until I go to my next slide, which will give me a better base to ask the question. So the other important thing with web services is the wire protocol. The wire protocol is based on XML. And XML is like known to every developer who is into software engineering now. So it's a very known, understandable, well-used protocol or a structure on the wire. So that makes things easier for people to appreciate. So it's not a totally a new protocol introduced by somebody. It's out there. It's people know that. Thanks to James Class, who came up with a brilliant idea. So it has made things easier, and therefore it gives automatic interoperability on the wire. The moment I say I'm going to talk to you in XML, you know how to understand it. I don't have to share another specification or a document with you to say, well, this is what XML is all about. And there are many standards which are all around web services. Very importantly, accepted by many large software vendors like Microsoft, Oracle, IBM, BE, and so on. And of course, there's a lot of criticism around web services standard. But there's a very valid reason why some of these things are not to the expectation of some of us. Because when you put these big players into a room and ask them to come up with a common standard, and they have their own, way of thinking and own agendas and all that, but I'm glad that they have at least managed to, agreed on this level. So let's not expect anything beyond that, right? So, this is how the service discovery and standard interaction happen at SOA level, at web services level. And this is pretty much what's defined at the outset when you talk about SOA. So if you do web services in this way, it's kind of aligned with SOA. So let me ask you a question. In your day-to-day web services development, let me repeat, web services development, how many of you use service brokers? How many of you have written an application where it goes and registers services themselves in a broker, and other consumers go and look up a broker to find the relevant services and make use of it? One. So don't get offended. Now you get the point. Because as per the architectural style, SOA, it's by definition, there has to be a service broker who knows about available services, and you can scale it and do all kind of things, make it fail over and all that. But services need to register with it, and others need to discover the service via that. You can't hard code the endpoints. So if you're not doing that, that's not SOA. So therefore, there's a clear example. Web services. So it's not bad. The fact that you are not doing is not bad. It's just another use case of web services. But my point is, web services is simply an implementation technology, and there are other use cases for that. And applying that in SOA is just one use case. Okay. I stated about open standards. So at different levels, these are the open standard web services provide you. So I'm trying to build the case why web services is a good technology choice for you to implement SOA. So it can facilitate the service discovery model, as you may have seen in my previous slide. And it has set of standard agreed by major players out there, and now has become like de facto standard. At each level, when it comes to communication, meaning the transport, there's HTTP, XML, SOAP, and WS addressing. And to describe the service, there are a set of standards. There's a standard way of describing a service so that we can understand. And there are standards to provide you quality of services in an interoperable manner. There's a standard for security. There are a couple of standards for security. And there are standards for reliable messaging and transactions and so on. So this gives a base foundation where you have the set of agreed upon standard which can be used to implement a SOA. So let me give you a brief moment to absorb the content here. These are all important quality of service attributes in enterprise application development. Yes, it's a long list, bit overwhelming. But let me give you another viewpoint. If we can have coverage over these main aspects, I can assure you have a very good coverage on the underneath set of quality of service attributes. The application we build has to be usable. So there are two usability aspects. One is usability for the end user. One is, if that is infrastructure, usability to the software developer. Security is very important. And there are many elements when it comes to security. Reliability get extended in many forms. When I say it's reliable, there has to be fault tolerant. So throttling has a role to play in it. Clustering has a role to play in it. So when you cluster, there has to be some means to load balance. And we should be able to handle concurrency, meaning there has to be some means to handle transactions. So what about performance? So there are two aspects when it comes to performance. One is performance experienced by a particular user, or a performance you can gain by a particular connection. And when you load the system by means of adding more users or maybe putting a lot of data, the overall level of performance the system can put out. That's been handled by the scalability. So the first level of performance is simply the infrastructure and the efficiency you have built into the application you have developed. So that's mainly up to the developer, plus how well the infrastructure can perform and how good is the hardware and so on and so forth. But scalability means, again, how we can scale. Of course, there's scalability you can do at the hardware level by increasing CPU power, memory, and so on. But there's another much cheaper way to scale your application by using clustering and load balancing and so on. And then, if it is a mission-critical enterprise application, monitoring plays a very important role. There are many things which is important when it comes to monitoring. If something goes wrong, how we can notify it, what is the level of exception handling and logging you have, and whether there are proper monitoring mechanisms for that, and whether you can monitor the services you are running, and so on. And then, overall configuration management aspect of the software. So, at a higher level, if you have coverage in these things, then you have good coverage in the underneath quality of services I have listed before. Now, this is something you can expect, most of this, except for maybe usability, is something you can expect from the underneath infrastructure or the runtime environment. So what is the traditional approach people has taken to handle this? Now, if you're building enterprise applications, and if you want to do web services, the web services obviously need to provide this. And there has to be some infrastructure in place which can take care of this. So, traditional web services containers has decided to take an approach like this due to related reasons again. So if you look at J2EE application servers, they already has most of these things. So why do you want to redo it? So let's make use of what we already has. And if we can add a web service layer on top of that, we are good. Very natural thinking. So that's fine. So people did that. And you have application servers, JEE application servers, which are web services enabled now. So what you would do, you will write an EJB and make it a web service. Or of course, later on with the EJB 3.0 standards, it can in fact support POJOs as well. But the reality is, still it's the already existing app server which is extended to support EJB 3.0 extension, right? It's not something written from the scratch. So this is where the difference. And then you will find ESBs, referred as Enterprise Service Bus, implemented using JMS, because JMS is a reliable messaging mechanism already available under J2EE, so people make use of that. So, at a higher level, if you look at it, it's an abstraction provided on top of the JEE containers to enable web services development. So we see a problem here. The problem is JEE's set of specification has coverage across so many areas, and JEE app servers obviously has to implement that. So when you want to develop a web services platform, you just need most of the time like 25% of the features available in these environments. And that is the reality 75% of the time. The rest is just baggage you have to, live with. And the other problem is the agility or the flexibility they have to adopt changes and support for different aspects and use cases of web services. Because they have to already cover a wider spectrum of things which are defined by the JEE standards, they have enough work to do already. And now, on top of that, they have to support web services standards. So this is too much work. As software engineers, we jolly well know when there's too much scope to tackle, how difficult it is. And how your application can become overcomplicated, difficult to maintain, buggy and all that. So you can't get away from that. So this has been proven by many of the instances when we try to interop or integrate with existing solutions with other technologies. And this is another complaint against web services. And I have heard that in many talks, that people complain about it, saying, web services are supposed to deliver all this, but they haven't been able to do that. Simply because the specs are good, but the implementation are not that good. So let's not shoot the messenger, right? The problem lies somewhere else. And of course, the problem with the large footprint. And nowadays, if you download can you even download an app server just like that? It will take nights to download it. Yeah? It will find it difficult to fit into a CD nowadays, the installation. So the different level of thinking we propose is this. So why do we need all these other things? You don't need all these other fancy EJB and all that stuff if you are into web services. You can do that with a Pojo container. And when we do design, we should be able to design things at a higher level and stop at when we design the web services interfaces. And treat web services as the primary citizens in my design. That will make life a lot more easier and our implementation and the design much more closer to each other. And of course, we should handle the wire level protocol then and there. So the container should be completely based on the wire level protocol. And there are a lot of agreed upon standards defined by web services. You should simply make use of that. Not any other technology or any other standard, because they are not interoperable across different platforms or different technologies. So this, we believe, this will help us to come up with an agile, flexible, modular design for a container, which can change things faster, rapidly, and performs in a much better way than traditional containers. And we can end up with a smaller footprint because our requirements are now very nicely defined. We know our scope very well. So such a thing will be a true web services application server. Not a court, put on something else. So do we have something like that? Yes. We have something like that. And that is called WSAS. And it's an abbreviation of the term Web Services Application Server. So what are the features of this product? It's a completely an open source product, licensed under Apache 2.0 license. So if you are not very familiar with Apache license model, it's a very liberal license. It's free software, you can download it and use it. So there are no commercial versions versus free versions as such. It's simply free. And anybody can actually contribute to that and use it as many number of copies you want. You can take it and modify it and use it, or put that into an application which you are planning to sell and do all kind of stuff. And it has comprehensive support for WS star. WS star means all the web services standards. Why? It is based on the proven Apache Access 2 web services engine. So there are two reasons why we picked Apache Access 2. One is the level of support it has, and the other reason is a lot of Apache committers are behind WSAS. This is a very natural reason. And it's definitely a Pojo container. But of course we know we can't come out and say, now replace everything you have and use this. That is not a very practical approach. So we have to coexist with others. We need to appreciate the effort put up by other people and live with them and interoperate with them and integrate with them and work with them. Therefore, we have support PJBs. We have a concept called proxy services. And you can, in fact, deploy scripts as services and run them. Basically, we have support for JavaScript. Theoretically, you can support any script which can run on the Java runtime. It's a matter of writing a deployer to deploy that script. We have very good QoS coverage, which I will look into in a short while, and it's improving. Of course, the current version of the software is 2.2.1, and in the upcoming releases, there will be many more QoS features added on to the software. And it has good IDE integration. We have picked Eclipse as the IDE because we are an open source project. So we have to pick another open source project which follows similar license model to integrate. Otherwise, there will be conflicts in licensing agreements. And good tooling support. So this is the high-level architecture. Have you used Spring? A very similar model. So currently we have Hibernate as the OR mapping layer, and Axis2 Web Services Engine at the core as the core Web Services Engine, and a lot of other Apache projects which are implementing Web Services standard put together around the engine to facilitate different specifications. And Apache Axiom is something I would like to mention, which gives an object model to XML, which actually you can use within your application as well. And we have a standalone server which runs on embedded Tomcat. Or, to my previous statement, the fact that we have to coexist with others, if you already have a J2EE infrastructure, it's not fair for us to say, throw that out. So we have built this in a way you can run this within that container. So these are the standards we support. And we are adding more to that. And as you can see, there's pretty good coverage which will give Wasa's applicable for 95% of the use cases you have out there right now. In fact, I think 100% of the current use cases, and if you look at the coverage we have. So these are the transports we support. So while you highlight on transport, as I told you, it's a very modular architecture. Each aspect of a service interaction we have modularized. So transports are treated as separate modules. Of course, when you say web services, it should be over HTTP. But in reality, because of the openness of the standard, the fact that people has agreed on these standards, this is something you can apply in many other use cases. So we have a mail transport where you can actually talk to this using mail protocols like SMTP, POP3, and IMAP. You have a TCP transport, you can run this as a TCP server, so no HTTP, nothing. An XMPP transport, I have used IAM tools. Obviously you are using IAM, some IAM tool. Every developer is using IAM tools, yeah? So XMPP is a very standard popular IAM protocol. So you can actually type a payload on something like Game or Pigeon and send it to a server and you can get a response, which runs on Wasas. And support for JMS, when it comes to integration, and many file transport. So currently we have standard file, SFTP, FTP, zip, tar, all that stuff. So if you have any use cases, this gives a lot of integration capability. The key attractiveness of the technology is the ability to integrate. So we should facilitate that. And the abstraction is that the transport, everything else is the same. And when it comes to messaging, these are the levels of abstractions we are having. We can, obviously we should support SOAP if it is about web services. And we have inbuilt support of REST and POX. POX stand for plain old XML. So, without SOAP bindings, you can simply send XML messages as service request. So REST support currently include these 4 HTTP methods: post, get, put, and delete. And we do JSON serialization. JSON is a well-known, popular, accepted serialization used by JavaScript. Right? So see, we have support for JavaScript services. You can run JavaScript services and enable JSON as the messaging, and then it will talk native JavaScript. And XML binary serialization, we use the technique called fast info-set. How many people has used fast info-set or some XML binary serialization? Do we have any? 1 or 2? Then probably I should not state who wrote that implementation. That's a joke. Right. So this is the tooling support we have. We have integration to Eclipse. So this is a picture of Eclipse, which has SAS tooling enabled. So you get all these management capabilities within the IDE itself. So basically you can develop your application within the IDE and launch it, deploy your services within the IDE. So without having to get out of the IDE, you can get almost everything done. And we have some online tools hosted in this URL. Well, it's not very clear in the slides. It's wso2.org/tools, the URL. You can go to that URL and make use of these tools, even though you don't have the software with you. Of course, you can download the software, it's free. And if you download the software and run it, you get the same tools available within the software itself. But the good thing is it gives you a URL and a nice set of steps in a wizard, which we can use to generate WSDL from the Java, or Java to WSDL, and WSDL to many other codes, like PHP or C or C++ and so on. So let us talk about quality of service aspect. How do we provide quality of service within this container? Now, if this is going to run as a separate container without any support from JEE, we should be able to give you all the quality of services required by the enterprise within this container. So let's talk about security. Now, there's a web services standard for security, so we make use of that. So there's a security token service which is used to issue the secure tokens. We call it RAS, and it comes as a module in the application server. And WS security standards are implemented in Rampart. It's another module. So all these are modular designs, components within the container. When it comes to reliability, we use WS reliable messaging specification to provide reliability, and the implementation is called Sandesha, which is another module. Now, of course, lately we have come up with another implementation for WS reliable messaging. We call it WSO2 Mercury. So you can replace Sandesha 2 with that and use it, but it currently works with the latest version of WSAS. But the point I want to highlight is these are simply modules. And if you can write a better module to serve something, or a module to give some additional functionality, or another implementation of a specification, you yourself can add it. If you don't like existing module, you can just get rid of it and add your own module to that. So everything is built like that. And you can actually implement these things because these are open standard, they're out there, right? Everybody has access to that. And our implementation itself, open source, the source is out there, so you can have a look and see how it has been done as well. In terms of fault tolerance, another important aspect of reliability, we have introduced a throttling component which can be used to throttle the incoming requests to a web service. So that if there's a DOS attack, or if a web service is driving another backend service, like a mainframe service, for example, there's an amount you can load a mainframe. And we have a practical use case where we have to actually use this to throttle access to a mainframe. This can be used. And how do you provide high availability? So this is a configuration. So we have support for clustering. Underneath, we use a reliable messaging framework, which make use of group communication and so on. And the high availability configuration we recommend is something like this. So you can have as many nodes as you wish as backup servers, and you put a load balancer. We have our own load balancer, but you can use a hardware load balancer or your own one if you have a better one. And if a node fails, you can redirect the request to the backup server, and we have the ability to maintain the state across each instance on behalf of you. That you get from the framework itself. So, scalability aspects of performance. This is the high scalable configuration, which has some level of failover as well. Since there are 2 servers in each cluster, we call it a group. So the load gets balanced across clusters. And you can, there are many algorithms you can use. There are a couple of algorithms we support in our implementation itself, but as I told you, you can use your own one if you wish, or a hardware load balancer to achieve that. And again, the state is maintained if required. So, how about monitoring? So we have a set of tools written around the container to provide system level monitoring, statistics, logs, and so on. So this is a view of the logs, how you can monitor using the web console. So there's an admin console which you can log into the app server. In fact, we are in the process of abstracting the admin console to a level where you can run an admin console instance, and then you can point that to any instance you are running within the cluster, so that you can view all the nodes using a single admin console. That will be available in a future release. And you can look at the message flows. You can look at each of the message flow and figure out which modules are getting engaged for that, and change those configuration and look at what module is there, what configuration is there, and so on. All those features are available as of now. So in terms of configuration management, there are a set of management services available, and without having to deal with copying files and editing XMLs and so on, you can deploy web services components or modules for the app server and upload it. So this is a view of the services configuration menu. And this is a view from the module configuration menu. So as you can see, you can upload your own modules if you wish and activate them. We use the technical term engaging a module for that. And other configurations like login and shutting down the server in a graceful manner and a forceful manner and so on. So in the graceful shutdown, we have built that in such a way when you issue the shutdown request, the server will not accept any more new requests, but it will complete serving the already on-service request and then shut down so that clients will not experience any bad behavior or you will not have any unstable state in your application. Or of course, if something has really gone wrong and that doesn't work, you can force the server to go down. So all that stuff is built into the framework. So, in summary, what do we have? So we discussed the fact that in terms of an architectural style, SOA is a good architectural style. And we can make use of web services to implement SOA. And in fact, it's a good choice due to reasons like the openness of the standard, the fact that people have agreed upon it. And we discussed about the problems we have in the JEE world due to many reasons. And the new approach taken by the application server, a web services application server called WASAS. And it gives a good coverage across quality of services required by the enterprise application development. And therefore, you can call it truly a web services application server because you have web services as primary citizens there. And because of the agility we are having, we have so far demonstrated very good interoperability across many different technologies and across other implementations like .NET and so on. So these are some of my references. Again, the URLs are not very clear, but I think you will get access to these slides. Anyway, we'll have these slides available in wso2.org. Okay, any questions? So UDDI is an interesting question. So in a SOA implementation, you need to have some means to register your services and discover your services. So at that point, UDDI was out there and people just start using them. And in fact, when in many of the articles, you will see UDDI coming in. But we have felt that there's a better way of doing that. So we have come up with something called a WSO2 registry, which gives a very REST API for you to not only store service artifacts, in fact, anything which can be, put into a repository. But it has ability to tag things, you can search it, and you can apply authentication and authorization on the artifacts you have. You can apply version into that, and all that it's built in a very lightweight manner. And that's the one we recommend.
Can you implement the UDDI 4J with access to?
Sorry, UDDI?
UDDI 4J.
You can certainly, bring that in, like integrate that. But of course, we haven't thought about, investing into that. But if somebody wants to, contribute something, you're mostly welcome. Because this is the true nature of open source project, right? The community can drive the direction of the project. And if they don't like something, they can come up with a new implementation. Or if there's something missing, they can, implement and contribute it. And when others like it, they will start using it.
Okay, thank you.
So we are very flexible on that front. Like some other projects, we don't want to dictate as to what should go in and what should not go in and so on. It's completely driven by the community.
Excuse me. You said web services is just one way of realizing SOA.
Yes.
Yeah. What other ways of realizing SOA are prevalent?
Right. So you can completely build an SOA based on J2EE standards, like the protocols, RMIO, IIOP, and JMS, and you can use all that. And you don't have to bring in any web services.
That actually goes against your definition of SOA being discoverable, right? Can I make an RMI IIOP service discoverable? I am so far not aware of anything. Is there any?
If you do an integration with a registry like UDDI, you can do that. But you need to build certain things around it. So their complete infrastructure is not available, but that doesn't mean you can't do it. It's just an architectural style. Then you can decide what the implementation technology you want to use. So if certain pieces are missing, yes, you have to build it. But obviously that's why web services has picked up so much, and that's why the confusion has come up as well, because whenever you say SOA, you will see web services, because people have taken the approach to, use web services, and all these pieces are available as web services implementation. So it has become a de facto choice now.
Okay, thanks a lot.
Any other questions?
WSAS supports EJB also as web services, right?
Yes, the way we do it, so when you deploy Wasas in an EJB container, or in fact, even if you run a separate Wasas instance, we have a concept called proxy services, and then you can configure a EJB endpoint, and Wasas will expose that as a web service. So there will be a web service coming into Wasas, then it will do RMI or IIOP call to the EJB, and then serve that.
Oh.
So it's acting like a proxy.
Oh.
Is it through the use we have made it, or is just the runtime? Is it because of the runtime support?
Right. So your question is whether it's simply use of tools or we have runtime support.
Because in JWS or more recent versions we have annotations. When you actually annotate a class with as a web service, automatically it gets hosted as a web service.
Right. So the
further uses hosting of a web service, and even lightweight web services like this and Parla.
Right. So there are two aspects. Definitely you need to have support for tooling, right? Otherwise, people will not like, writing visitors and schemas and all that, right? So we have the tool support. Plus, yes, by design, the runtime is to do that. And the difference is, we have done it from the scratch. So we don't have to support any other things like, ability to run previous versions of things and all that.
Specific.
Sorry?
Okay, if I have to write a POJO and put it in Wasas to make it as a web service, what other artifacts should go into the deployment to expose it as a web service in case of Wasas?
Right. So there are two ways you can write web services, right? One is the code first approach, which you just mentioned. The other one is contract first. So Wasas support both. So if you just have a POJO, you can just put it and make it a web service. You don't have to do anything. It will generate the WSDL automatically, and if you want to engage security or RM and all that, you can do within the admin group. So that is, of course, tooling support. So the required schema and that stuff will be generated by the framework automatically for you.
Thanks a lot.
Spring. So Spring is a very popular POJO container. So Spring also has web services, but they have taken a principal decision as to, web services should be only contract first. So it's only support contract first. So we have come up with a complementary solution